Law. So the ideal gas law is the formula that you see right here. PV equals nRT. Now P is for pressure, V is for volume, measured in liters, and pressure is measured usually in atmospheres. There are some other measurements for, well, units for pressure like kilopascals, which would be like kPa, etc. Then N over here on the other side of the equals is moles. R is a universal gas constant. And then T is for temperature. Temperature is in Kelvin. Now R normally is 0.0821. But that's only when we have these four units for the other ones. When we have liters for volume, atmospheres for pressure, moles for N, and then Kelvin for temperature. When all of those units are the same, this is the number we're going to deal with. So if you're not using those units, then this video will help you, but you might have a different value for your R constant. So just keep that in mind as you are doing your ideal gas law problems, that the R constant can have a varying value depending on what units you're using. So if you're using these four units, then you should be good to go. All right, so just keep that in mind. Secondly, let's do a practice problem. So if I have 4 moles of gas at a pressure of 5.6 atmospheres, ATM, and a volume of 12 liters, what is the temperature? So anytime you get a question for ideal gas law that is worded like this, what you're going to want to do is, number one, just identify what is this question asking us to find. Well, this question is asking us to find temperature. Okay, so we know we're going to try and find T, meaning that we're going to want to get T by itself. So what's going to end up happening is you will eventually divide NR on this side, and whatever you do on one side, you have to do on the other, right? Because if we divide that, this is going to cancel out on this side, leaving T by itself. So in other words, what we can say is that T is equal to PV over NR. Now here's the thing that we do know. The rest of this is what I like to call plug and chug, because that's really all we're doing here, is looking at the values that are given to us and just plugging them in. So let's start with pressure, P. That's 5.6. So 5.6. I don't always write the units in this just because sometimes it's not that important until the end. Then we have V for volume. Some of your teachers and professors might say differently, but that's okay. Just do what they want you to do. N is 4 for moles. And then R. So this is where that R comes into play. R for us is going to be 0.0821. And that's just an agreed upon constant value, meaning it's going to be the same thing every single time. And like we were saying before, it's only when we have these typical units. All right, so T is going to be measured in Kelvin, so our answer for T is going to be in Kelvin. And this is equal to T. So let me erase some of this. We can get some space. It's going to be 5.6 times 12 on the top. And that's going to give us 67.2. So if you're doing this on paper, you obviously don't have to erase and rewrite. I just like doing it. It makes it more clear of what's going on. Then we're going to multiply the bottom together. 4 times 0.0821. That gives us 0.32. We could round that to 33. So 0.33. And then we're going to do 67.2 divided by 0.33. And that's going to give us 203.6 Kelvin. All right. I kind of know it's in Kelvin just because of the way this R constant is given and the rest of the units are in. All right, so hopefully that kind of makes sense. If you have any questions, comment them in the stream below here on YouTube. Appreciate the support. If you like this video and it made sense to you, drop a like. Thank you.